Hello everyone. Now we are going to discuss in detail about the outdoor substation. So in the case of an outdoor substation, first you will be receiving your incoming supply at 11 kV. So this is an 11 kV supply, and then first it is going to a gang operated switch and 11 kV lightning arrestor. So there will be lightning arrestor in order to protect the system from lightning, and there is a 11 kV gang operated switch, that is nothing but an air brake switch, which we will discuss in detail. And then we will be having an 11 kV horn gap fuse. Horn gap is the name because it is looking like a horn, and that is why it is a horn gap fuse. That is similar to a normal fuse which you are at a house, and the thing is that it is for an 11 kV supply system, and from there it is going to be taken to a transformer which is 11 kV by 14 volt transformer, and from the transformer through a 3.5 core LT cable it is going to a LT switchboard, main LT switch, and that will be having a switch fuse unit in order to protect any kind of faults which is occurring at the downstream of your transformer. And then it will be going to the distribution low tension switches depending upon the capacity of the system. And here this transformer, you can see that it is a delta bar star system. So at the secondary side you will be having 4 cables will be there, that is R, Y, B and neutral, and that is why it is written as a 3.5 core LT cable. And what is a 3.5 core? You will just see it over here. So this is a 3.5 core. So totally 4 cores are there, 1, 2, 3 and 4. In that you can see that this core, the second one and the third one are of 25 square mm, but the last one, the fourth one, is nothing but a 12.5 square mm cable. So that 12.5 square mm is being utilized for the neutral conductor, and the other one is being used for the R and Y and B phase. So in a balanced system the neutral current is supposed to be 0, but that neutral capacity is in such a way that a half of that other phase poles are taken for the neutral conductor. Now we will see certain parts of this gang operator switch, the horn gap fuse and the transformer bushings in the next slides. So this is just indicating a transformer. The transformer will be having an oil tank will be there in order for the cooling purposes. Then the major thing we need to focus is nothing but a bushings. So this is nothing but a bushing. This is a high voltage bushing and this one is a low voltage bushing. So you will be 11 kV supply from your horn gap fuse will be coming to these high voltage bushings, and you will be taking your LT cable. A 3.5 core cable will be taken from these 4 terminals, and this is taken to the LT switchboard. Now we will see the air brake switch, and this is the figure of the air brake switch, and this is a gang operated air brake switch. Gang operator means you are having the 3 terminals are there, 11 kV supply, 3 terminals are there, R, Y and B, and those R, Y and B terminals are nothing but these ones to which your supply is coming. And this gang operator switch means using a single lever you can isolate all the 3 phases at the same time. So here you can see that when the gang operator switch is in the open position it will be like this, and once it is, so this is in the open position, and once the gang operator switch is closed, then this terminal will be moving on to this and attaching to the system, and therefore the supply comes in line with the system. So under any case of maintenance in any kind of the transformer, then you will be operating the air brake switch in order to ensure that safety of the working personnel. Then you will be having the horn gap fuse, which is known as the HG fuse. So HG fuse is nothing but this is looking like the horns, and that is why it is known as a horn gap. And you need to also have a fuse element. The fuse element will be very thin in nature. It will be just inserted between these 2 terminals, and the fuse element will be very small because at 11 kV though at high voltages the current will be very small, very few current will be passing through the system. So under any kind of fault which is occurring at any of the systems, then this fuse will blow off and thereby protecting the system. Now we will be going on to the H-pole structure, and we will be discussing the transformer substation. So here you can see your air brake switch. The air brake switch is there. Then you will be having a lightning arrestor is there, then you are having your 11 kV horn gap fuse. So normally I used to take you to the our substation in our college near to the canteen to show all these parts. But for the time being, we have to adjust ourselves to our lecture itself. So here you can see your transformer. This is nothing but your transformer. And this is a two-pole structure. We have said that on the two poles, you will be having the MS channels and you will be having a platform on which you are keeping your transformer. So that the transformer is nothing but this one. Now, the 11 kV supply is coming to this air brake switch, which is a gang operated. And you can see that the lever of that particular air brake switch is coming down like this till here, and then you're having your handle, and that is at 1.25 meters from the ground level. So this operating handle can be operated in order to open or close your air brake switch. Then you will be having your lightning arrestor, and from this lightning arrestor it is coming to the horn gap fuse, 11 kV horn gap fuse. You'll be having the fuse element will be there, and then it is coming to the transformer high voltage bushings. You'll be having the 3 high voltage bushings, you can see it over here. And from there you will also have your low voltage bushing on the other side of your transformer. From there it is taken to a 3.5 core cable onto your LT distribution box. So this is nothing but an LT distribution box. From there it is taken to your inside system. You'll be having your LT switchboard will be there, and you'll be using that. So you can see here that what is the height at which the transformer is to be kept at 2.4 meters from the ground level. The LT distribution box should be at a 2 meters from the ground level, and you also have to keep a danger sign onto this system to show that it is at a high voltage level. So this LT core cable you'll be having through a service line, or through a cable you can take it to the substation, inside of the substation. So this is the side view again. The horn gap fuse, lightning arresters, then your transformer, then your operating handle of your air brake switch. Now your outdoor substation has to be earthed. So you are having a double pole structure, and the double pole structure is shown over here. This is the double pole structure, and you need to have a 3 earth pits is required, pit number 1, 2 and 3. So there are 2 earth pits on either side of your double pole structure, and one of them should be connected to the lightning arrestor, and the other one is to be connected to the neutral of your transformer on LT side. And you will be having a third one, and the third one to be connected to the transformer body, to the handle of your gang operated switch, and to the body of the LT switches. And there will also be an interconnection between the 3 pits in the case of a outdoor substation. So that is all about our outdoor substation. So these things we can also see on the transformers which is kept on the roadside. So you just have an observation on your distribution transformers kept on the roadside near to your house. So you'll get a better understanding when you see it on a real basis. Thank you.